Alrighty, let's take a look at page 391, question 9. So here we have a particle of charge negative 7.9 microcoulomb, and it is moving at a speed of 580 meters per second. So charge is 7.9 microcoulomb, which is equal to negative 7.9 times 10 to the negative 6 coulomb, moving at a speed of 580 meters per second. Now here's some details about how the particle is moving and how the magnetic field is oriented with respect to that movement. So we note first that both the magnetic field as well as the motion of the particle is confined to the XY plane. Okay? And so here we're told that the particle is moving at an angle of 55 degrees with respect to the x-axis. So the particle is moving at an angle of 55 degrees with respect to the x-axis. Okay, so this vector right here is the velocity vector. Okay, and we are told that there is a uniform magnetic field that has a magnitude of 1.3 Tesla that's parallel to the y-axis. Okay, so the magnetic field is oriented with respect to the y-axis. All right. Now, the one thing that we need is the angle between the velocity vector and the magnetic field, and that is what we're going to be plugging into our magnetic force equation. Okay. So in this case, the angle here, we have to do 90 minus 55, so that's going to be 35 degrees. Okay. And now we're all set to calculate the magnitude of the magnetic force. Okay, so we have the magnetic force Fm is equal to QVB sine theta. Okay, so we have Q is negative 7.9 times 10 to the negative 6 coulombs. V, the speed is 580 meters per second. The strength of the magnetic field, I forgot to write that down, is 1.3 Tesla. And the angle between the velocity vector and the magnetic field is 35 degrees. Okay. And so, when we plug this in, let's see what we get. One thing to point out here, that negative sign, again, that negative sign is just telling us something about the direction of the force. But we'll get to that when we figure out, or when we start to apply our right-hand rule. Okay, so let's see what this will end up getting us here. So 7.9 is negative 6 times 580 times 1.3 times sine 35. Okay, I get a magnitude of 3.41656 times 10 to the negative 3 newtons. Or how many sig figs do we have? 2 sig figs. So approximately 3.4 times 10 to the negative 3 newtons. Okay. Alrighty. And now let's kind of figure out the direction here. Okay. Now for this, what we almost want to do is draw a three-dimensional problem here. Okay. So, or draw a three-dimensional grid for this problem. So we'll have our y-axis, or rather, here, let's make this x, y, and I'll move this down a little bit. X, y, and z. Okay, so we have our x, our y, and our z. So again, let's fill in the vectors that we had up here. So the magnetic field is parallel to the y-axis, so that'll be like this. There's our magnetic field. Our velocity vector is 35 degrees towards the x-axis, so our velocity vector is still in the xy plane, but it's doing something like this. 35 degrees away. Okay. Now to do this, we have to use our right-hand rule, right? So the right-hand rule states that we point our thumb in the direction of the velocity. So here we use our thumb. Our pointer finger points in the direction of the magnetic field. So pointer and then our middle finger points in the direction of the magnetic force. So in this case, because our thumb points in the x direction, our pointer finger points in the y direction, the magnetic force will be in the z direction. Or at least according to the right-hand rule, we'll note that the magnetic force points in the z direction. That's going to be our middle finger there. Okay. But there's one thing that we really have to pay attention to here, and that's the fact that the charge is a negative charge. Okay, so now the negative charge, what that tells us is that the direction will actually be opposite to what we think it is. Okay, so here it seems like it points in the positive z direction. Okay, but because we're dealing with an with a negatively charged particle, this will actually flip. Okay, so this is going to be the actual magnetic force. Okay, so Fm is not up here. Fm is actually going to be down here. Okay, and again, the reasoning for that is the charge is negative, and so the right hand rule, we have to be careful and turn it to the negative z direction. Okay, and that's about it.